Hello, I'm Ernst, and today I want to show you how precise you can measure with an oscilloscope with very low noise levels. So first of all, I want to show you the analog front end of the RTO oscilloscope that you see here. I removed the shielding. You see the input, you see the dedicated analog front end chip that is responsible for the amplification. And behind here you have our own custom AD converter that in the signal path together with all that ensures low noise, including with the shielding that I can add again. We have a low noise front end and we have a very low crosstalk between the channels. The crosstalk is as good as minus 60 dB. So that's really very good. When I now turn to the oscilloscope, here you see an RTO with 4 GHz that's set to a measurement range of 1 volt. And when you have that measurement range, we measure around 3.6, 3.7 millivolt per noise, which is shown on the bottom here. And you see this is less than 0.5% of the full scale range. So less than 0.5% of your measurement. Another example, we can turn to 100 millivolt measurement range. This is what we have now, plus minus 50 millivolt, 10 divisions. You see our noise level is 0.35 microvolt, again on a 100 millivolt signal, less than 0.5%. And please note that always we do have the full bandwidth, no matter what vertical scale you use, from 1 millivolt per diff to the full range. So there's no bandwidth limit in here as well. So I hope that demonstrates how well you can measure, how accurate you can measure with an oscilloscope that is optimized for low noise, as you see here with the RTO oscilloscope.